last week, and it was an American guy, and he basically said how he's been told he gives a presentation like he's on cocaine because he speaks really fast. So now you've only given me 20 minutes, I might be flying through, so I better get cracking. Look, if we look generally, cattle are pretty much sold two ways. So they're either sold on live weight through the sale yards, or they can be sold on carcass weight over the books type sale. So cattle sold on live weight, generally the price is predetermined on a cents per kilo rate. Now this is based on a subjective judgment of the buyer. So it's based on live traits exhibited in the cattle, such as frame, muscling, shape score, age, an estimated weight and fatness, sex, breed, are all contributing factors into what that buyer might give you when your cents per kilo rate. If you look at cattle that are sold, sorry, can everyone hear me? Yep. If you look at the cattle sold on carcass weight, it's generally sold on a grid, which is a predetermined amount, again looking at cents per kilo rate. So factors that will impact on this is grade of the animal, so whether they'll be classified, dentition, butt score, which is a subjective measurement taken, and if you look at the objective measurements of fat at the P8 site and also carcass weight. But the moral to the story in all of this, although MSA, if you go back to the grade, there are prices in the grids for MSA scoring where it does factor in some quality traits. Essentially, most of cattle, they're predominantly sold on yield characteristics, and and that's because today it's where we put a lot of the carcass value into the animals. So how will we sell in the future, I guess, is the big question. And it's a bit of a dark term to talk about value-based marketing, but really if we want to define that, it's really where you as a producer is getting paid for what you're actually producing, so and what the supplier actually, or the customer of yours actually is desiring, and the feedback systems are replicated in the price that they're actually going to pay. So if you're meeting specifications including quality traits, you're going to get paid a much higher price if you're meeting what they're desiring. So is this the way we're going to head in the future? And I guess the question is, how do we actually achieve this as an industry? We know that we can determine yield traits to some degree, but how are we actually determining quality traits as an industry? So if we look at the actual use of value-based marketing in Australia currently, it's really non-existent, especially when it comes to meat quality characteristics. Why? Well, if we look at this machine next to us, I'll just sort of go through. There's currently really no non-destructive measure to actually measure meat tenderness, which is, as a consumer, a high desirable trait. We want to be producing meat that's at a high level of tenderness on our Australian domestic market in order to get repeat purchase. So we've only really got indicators of tenderness that we use in the industry at the moment, such as pH or marble score. So if you look at this machine next to us here, this is what we use currently in the lab like in our experiments to determine meat tenderness. So this is actually called a shear force machine, and essentially it does what it says. It measures the amount of force it takes to cut through the piece of meat. In order to achieve this, we need to take a sample of meat, we need to cut it to a specific specification and size, then we cook it for a specific period of time, then we again slice it up into a specific sample size and then measures the force that it takes to cut through. So as you can imagine, it's actually quite a time-consuming task and an expensive process, and it's not commercially applicable. So we need to look at other technologies that potentially could measure tenderness. So in the processing world, as I've just highlighted, really there's a lack of objective tools that can measure meat tenderness or other meat quality traits. I'm just using tenderness as an example because a lot of us can relate to meat tenderness. So if we look at research and what's been happening, there's been decades of research into these online measurement technologies in order to predict both beef, carcass quality and yield characteristics. This research has largely been driven by the need to satisfy consumer demand. Our consumers are our most important asset. If we can keep satisfying that, it relates to and equates to repeat purchase. It's also been driven for you as a producer to provide more accurate feedback so you can make more informed decisions about maybe your nutritional program or your breeding programs. And then I suppose there's got to be benefits for all involved. So it's also from a processor perspective, it's been driven by the potential ability to reduce labour requirements in the processing industry. Labour requirements is one of the most expensive costs to the processing industry. So if we can do and develop technologies that are potentially automated, there's a benefit for them too. So to define, you guys might be sitting there going, I've never heard of an online measurement, what really is it? Well, we can simply just define it as a technology that can measure a carcass trait in real time. So either whether it's taken on the kill floor or sorter floor, or actually in the chiller. So, and it can measure potentially either yield traits or quality traits. In order for an online measure technology to be successful, it needs to be fast, it needs to be non-destructive. We can't have the caper that we're doing currently to measure tenderness because it's just, we want to be able to sell the product at the end. So it's got to be non-invasive preferably. Once you start getting a technology that's invasive to the carcass, we start running into hygiene problems. The technologies also need to have a high level of accuracy. If we were to implement a value-based trading system, we need to have a lot of assurance that what we're measuring is that highly accurate if we're going to be paying you a price based on this measurement. It also needs to be cost effective. We can't spend billions of money developing a technology that might work if it costs too much money to run. Energy costs are a big factor in the processing industry, so we need to look at technologies that can be efficient and cost effective. And in an ideal world, we'd like it to be able to measure more than one trait at a time. So if we can have a prediction of, meat colour as well as tenderness, as well as purge loss potentially, it'd be good. A highly critical thing for the processors also is that it has to maintain and fit within their hygiene requirements. So it'd have to suit with them. And then ideally, a new technology to be great to already integrate it into a system which is quite well known, such as Meat Standards Australia. So if it could already be linked in with a quality assurance program or a branded program, that'd be another benefit for the technology. So I'm just going to go through a couple of types of online measures that we've either been working on in industry or that we're, so they might currently be a bit commercial, or there'll be ones that are definitely research orientated. So one of the most common ones that's been around for quite a while is video image analysis. And it kind of is what it says. It's taking a picture of it and an image, and then it's analysing. So if we look at the one that's been developed for beef carcasses, this is just an example of a machine. So what actually happened? Do I have oh, thanks. Do I have a light?
Yep.
Oh. Sorry people. I should have had this worked out. Oh, there we go. Missed it. I'm pressing too hard. So basically, the beef carcass will pass through here, and then there's a camera inside there. Camera's inside there, and this is just a picture of the camera. And what it'll actually generate is an image that looks like this. Now, the idea of this image is to try and ascertain how much fat is in the carcass and proportionate to the lean muscle as well as to the bone. So this technology is aimed to actually predict lean meat yield, and by lean meat yield, it's the percentage of lean meat muscle of the carcass. It's also been developed overseas to predict saleable meat yield of some cuts. So by saleable meat yield, it can actually incorporate bone and fat. It's actually a product that will be sold and weighed proportionate to the carcass. So if you're actually producing a product that is actually over fat, so falls out of spec, it's got 20 mils of fat on it, the specs only wants 10 mils of fat, obviously you're going to get a lower saleable meat yield percentage there. Thanks. And also it'll take fat colour as well. So this type of technology has also been applied to video image, to the beef chiller assessment. So this technology actually will measure marbling, and as you can see here with the blue, it's highlighted the marbling of the muscle, and it'll give it a marble score. It'll predict meat colour, fat colour, in addition to the eye muscle area, so that's outlined by the green line going around, hopefully you can see it at the back. The rib fat depth, which is indicated by the pink line here. And as you can see, this fella's pretty fat. Additionally, we'll make these predictions again on saleable meat yield and lean meat yield. So this original technology was developed by the Danish. It started off being developed by the Danish, and then the Americans had a crack at developing the technologies, and we in Australia also have spent a lot of R&D funds into developing this technology. Commercially, it's not widely used in Australia. It is used in Europe as a part of the classification scheme. So it's been proved, and there's been a lot more development in Europe in more recent times to get it to perform as a classification scheme. Studies that they've done there have shown that it really takes a subjective view from chiller assessors out, and so there's less error, it's more accurate than their previous system that they had in place. In order for this type of system to become, just to go a little bit technically, to become more successful, the more information that we put into it, the stronger the algorithms actually become, so the more valuable the information we can get out of it. So they've done a lot more development overseas. The adoption strategy here in Australia probably hasn't been as successful as we might have liked given the amount of investment that we put into it. This is a spectroscopic method known as the Hennessy grading probe. I'll just talk briefly about its history. This probe was actually designed to work in the pork industry. It's widely used in the pork industry in Australia and overseas. It was developed again by the Europeans. It's now operated by a New Zealand company. And it was designed for cattle. Well, then they tried to adapt it to cattle to measure just the P8 site, fat depth at the P8 site. It also has claims that it can make yield predictions and meat colour predictions. So how this one actually works is that there's it's got a knife that cuts through the piece of meat, and it's actually got a light through here that takes the measurement. And the readings actually happens so you push it in, and then it takes the measurement, let's say in fat depth mils, as the machine retracts. So essentially in the beef industry, it hasn't, again, been widely adopted. It works really well in the pork industry, and because it has worked well in the pork industry, they did try and adapt. But the way the muscles work, things are quite transferable between sheep and beef, but not so much between pork muscles, because the muscle structure is just so different. So, another probe. Looking at other spectroscopic methods, these NIRs, there's been a lot of work in near-infrared technology. The Americans have started trying to use it to classify carcasses. We in Australia, with New South Wales DPI and Vic DPI, have been doing a lot of R&D in this area. It's got the potential to measure certain traits such as shear force, water holding capacity, pH, which is definitely an important meat quality trait, meat colour, making predictions on sensory traits, as well as marbling. So this type of technology is certainly still very much in its prototype phase. It's definitely not commercial, still quite expensive, not really able to keep up to production speed, but there's definitely further work going on in this area. Another new technology is the ramen technology. We've actually got a PhD student based here at CSU, Steph Fowler, who's been doing her PhD in this, along with colleagues at DPI. This technology has the potential to predict meat tenderness, juiciness, cooking loss, and also the fatty acid components. Again, this technology is certainly in prototype stage. We've done a fair bit of work in the lab. Steph's done a fair bit of work in the lab initially, and then she's actually taken it out into commercial plant to try and get some recordings there. But you know, as you can see, a very fine jimmied up system of holding it up with a bit of string and a hook. So it's definitely just a prototype, working out on how accurate the results from this technology are. And if we look at some mechanical probes, I just wanted to show you this one. This is actually a sheep probe, so not 100% applicable here, but the point about this probe is that it was actually widely adopted by Australian processors, and it was a very accurate measure of the fat depth of the 12th rib, or otherwise known as your GR measurement, which is, if you've ever sold sheep over the hooks, it's a fat score that you'll get given back along with your weight. It was a widely adopted technology, but the company got bought out and they stopped manufacturing. So it got bought out by another company who thought that their technology would take over, and it just kind of didn't work. So this particular technology was well used and was quite accurate for measuring fat depth. Okay, so if we just talk briefly about some other technologies, I won't go into these because I've just been told that I've got 5 minutes. But essentially all of these are really experimental phase. We're taking technology used in the medical system. So I will just talk about CT scanning. We've got some colleagues working on that as well from DPI. There's a few logistical restraints around CT scanning, and I'll show you a picture of it in a second. But I will just touch on, I went to a conference in Hungary recently, and they were doing lots of development work, mainly in pigs and sheep. Solely because the size of a CT scanner is not going to fit a beef side through. We're using actual medical facilities. And where we went, it was at the university, and they had a medical science section and an agricultural science section. They had patients that used to come into the medical science section, and they also had pigs that they would be scanning. So by night they'd be doing the pigs and the sheep, and by day they'd be doing the patients. So we went there by day, and they were quite proudly showing us where they brought the pigs in. And so they came into this little area because they were doing live, they were doing it for breeding objectives, and they'd actually knock the pigs out in this little area. And then they'd bring them out to this area. And so we actually went, and there was patients lying up on the CT scanner when we were there, but by night they do pigs, so it was quite interesting. But I guess the point to all of this is very experimental. We're still working on it, but there's some high levels of accuracy in some of these technologies. So if we look at other current technologies, Dr. Malcolm McPhee and his team from DPI, as well as UTS, have been developing 3D digital camera technology to objectively measure. So back in my traits, so back in my first or second slide, I was showing you how live animals is really subjectively measured by a buyer. This technology has the capability to sort of, I guess, measure it objectively. So it doesn't quite work like this, and it doesn't quite work like that. We've got a GoPro strapped to a dairy cow here. The camera technology doesn't quite look like that, but because it's a new technology and it's still going through patents, I can't actually show you any pictures of how it works. But you just got to believe me that it has the capabilities to look at live animal traits, and make predictions on, or measure hip height, muscle score, P8 fat, and actually starting to make retail beef yield predictions. And also they've now started to adapt this technology to look at carcasses as well. And Malcolm, speaking to him the other day, he sort of indicated that the predictions of retail beef yield on the live animal and then cross-referencing it with the carcass measurements that they're getting, he thinks you'll get quite a powerful result there. So for you as a producer, it's probably of interest, that type of technology. So just to get into my sort of current area of work, I'm currently sort of trying to get into the psyche of processors and understand their perspective about online measures technology, because in order to get successful adoption, we really need to understand. So this has really just been achieved through a strategic survey that I've put together. I'm looking at beef, sheep and goat abattoirs. So I guess the question is, what will the outcomes be of this work? I'm hoping to have 3 key outcomes. The first is to identify any current barriers to current technologies that are around, and identify why they may or may not have adopted it, look at any potential future barriers to adoption, and then develop some strategic recommendations to hopefully try and increase the overall adoption of new technologies. If we as an industry are going to keep investing money into these areas, we need to make sure that we've got an end use for it. So it's quite important. So what will this mean for you as producers? Well, the big picture is I'd like to lovely say I'm going to increase productivity and profitability. But I guess how am I going to achieve this? And essentially the key is the feedback to you guys. If you need to make informed decisions on, your breeding, where you're going with your breeding or where you're going with your nutrition, you need to have the more feedback you can have, especially on the meat quality traits. Currently you're probably getting quite good feedback on your yield traits and know where you are there, but you're not really getting any on the meat quality traits, and that's obviously what's going to affect consumers' preference. So hopefully I'm going to be able to enable you as a producer to make more educated decisions on your breeding programs, ultimately better meet market specifications, and gain the opportunity to implement potentially a value-based trading system where you as a producer are actually getting paid for the actual product that you're producing. And hopefully if you're producing better quality products, you're going to be rewarded for it. So overall, we want to increase the demand of beef supply through greater consumer satisfaction, and that's going to be achieved through better meeting specifications on product quality. So my take-home messages, how to go, are basically that online technologies can be potentially a useful tool to better meet specifications and hence hopefully meet your consumer requirements. Producers hopefully could potentially be rewarded more accurately for producing a higher quality product. And the development of these technologies is going to be ongoing, so we really need to, in order for it to be successful, we really need to have a good adoption strategy in place.
Thank you very much.
You're welcome.
Thanks, Edwina. It's always a risk asking a